Hello. Today we're going to look at the advanced organic chemistry of the Suzuki reaction. And this reaction is very important in that you can develop new organic molecules from prerequisites. Right? The general reaction involves organoboron species. What we want to look at is this R group over here, and this R group is going to be coupled to this R group over here. In order for that to take place, we need a boron over there bonded to any other group in this case, and in order for it to react, it needs to react to a halide, an alkyl halide or an organohalide, in the presence of a palladium catalyst and a base. Once that happens, the two R groups are coupled and you get R1 coupled to R2. So let's look at an example. So what you do is you're going to look for the halide, the organohalide, usually the one with the halogen attached over here, and that is going to bond to this organoboron species. So here is your R group, and over here was that Y that you saw earlier. Okay. In the presence of palladium and your bases, and you can see there's your R1, there's your R2. If this was R2 and this was R1, that's what you get, and you can see that nothing happened to that sulfur group over there. It remains on the end carbon. So how this works is it goes through a catalytic cycle, right? And that cycle involves a metal catalyst called palladium 0 in this case. So what you can say firstly is the first step is the oxidative addition. This R group is going to bond to the palladium, and this X group is going to bond to the palladium, right? After that step, the NaOH base is going to, especially this butoxide, is going to extract this X group from the palladium. You get that group over there with the R group is still attached to the palladium. Now you can see that the palladium has undergone oxidation. Its oxidative state has gone from PD to PD to plus. So a byproduct, obviously, to extract this halogen, you need to take off that to get that X there. So you get your sodium, let's say it's bromide or chloride, comes off as a byproduct. Now you've got these the species over here. You need to add the R1 group to it. How you do that is through this boron, organoboron species. So the first step here is you add the butoxide basically to the boron species. It becomes negatively charged, and then this R group is going to attach to the palladium. You're going to extract this butoxide off. When you do that, you're left with the R1, R2, palladium 2 plus. You can see that there has not been a change in the oxidation state of the palladium. It has remained at 2 plus. What then happens is the R groups over here are close to each other, close enough to combine to become R1, R2 in a step called reductive elimination. So obviously the cycle is a summary of the processes, and especially this step over here can be a lot more complicated, and